it's not the one. Okay. So first one is reshaping the array. So in order to reshape an array,
చెప్పు వాళ్ళను మరి 11 కాగానే బంద్ చేయని చెప్తారా 3 రోజుల నుంచి చెప్తున్నా ఎవరు చెప్పట్లేదు మరి వాళ్ళకి.
okay, for reshaping guys there are multiple techniques are there. Just split up the whole numpy functions. Usually the people get confused with them, so let's categorize them. Okay, first one is reshape function. The reshape function will reshape. Now here the condition will be like this. You have to call this one using the array. Okay, you will be calling using the numpy array, and the desired shape should be, the product of the desired shape should be equal to the size of the array. Okay, the product of the desired shape should be equal to the size of the array. New shape, in other words I can say it as a desired shape is new shape. Okay, new shape of the array should be equal to is it okay? Can you see this? Right? Light off कर दिया तो हो जाता. Light off sir. Equal to the size of the array guys. Size of the array. చూసి ఫ్యాన్ లో ఆన్ చేయ, వీడియో ఆన్ చేయ, ఎగిరిపోతుంది అది. స్క్రీన్ కాదు, ఆ లైట్ దాని పైన ఉన్న లైట్. Both are same. Okay, that's fine. Now this is a one. The other one is
నేను నీకు పని చెప్తా, నువ్వు నాకు పని చెప్తా. వచ్చిందా అది? ఇదేనా, దీనిదేనా ఇది? రావట్లేదు. పోయి విలువ ఉంటే జస్ట్ అడుగు వచ్చింది, కూర్చో.
okay, there is next one is called as transpose guys. Transpose, this is also used to transpose. Usually the transpose is used to reverse the shape of the function. Shape of the function if it's two dimension. If it is more than 2 dimension, then what we will be doing is we will be using the axis to reshape the function. Okay, it is more than 2 dimension, then we are going to use the axis to shape the array. Okay, there is one more called as reshape resize is also there. Now resize is a bit flexible. Now in this case, the desired shape of the array should be equal to the size of the array, right? You can't give it more than that. No, you can't give it. in this case, you can give it. Resize, you can change it to your desired shape, which is not equal to the size of the array also. So you can give it over here. Change to desired shape without depending on size of the array, or depending on size of the array. Now this can be called multiple ways. There is one more called as swap access. Don't know which access or access. Let's see this. Now this is used to reshape the any two dimensions of the array, any two dimensions. Array. And there is one more called as flatten. This will flatten the array. If there is a 2-dimension array, 3-dimension array, 4-dimension array, so it will flatten the array based on the order. Okay, there will be an order will be there. There is there. There is two orders will be there. One is called as C, stands for contiguous, and R stands for fortran. So these are like, this is nothing but the row wise, row major. Row wise we will keep it as row wise flattening, and this one is column wise flattening. Now some people will call it as row major and a column major over here. You can also call it as, or it can be called as row major, and this is called as column major. Now, and there is one more there called as Rabble. Now, these all are the different ways. This is very much similar to that of flatten, guys. You will see a slight difference. This has to be called with an array, and this can be called with an Numpy. Okay? Numpy itself. Now, reshaping of the array. These are the different techniques of reshaping of the array, guys. Okay. Now, first one we know it. I will quickly repeat it. Now, size, resize, transpose. Transpose is very, very important. Swap access, flatten, and Rabble. Rabble has to call with Numpy, I think. Okay, now let's start with it, guys. Okay, now let's do this one. Okay. First one is, let me make an array. Np dot random dot rand int. I want to make an array with 4, 5. Okay, 4, 5. And this I will give it as array 1. Now, okay, ARY1, this is the array. Now I can reshape it using the ARY1.reshape, and you can give it the, make sure that the product of the new shape should be equal to the size of the array, right? This is a condition required. Now size, sorry, reshape, I will give it as like 2, 2, 5. Yes, we can do it like this. 2 into 2, 4, 4 into 5, 20. That is equal to 20 over here. Now, this is not a permanent change, guys. This is not a permanent change. I'm transforming a 2-dimension array to a 3-dimension array over here. This is not a permanent change over here. Now, you see this. I will say that ARY1.n. I do this, you will get it 2-dimension over here. Now, here, ARY, now this I want to change it. I want to make it a permanent means I have to store it in the same variable or the other variable. Now ARY2, if you see this ARY2 dot shape, you're going to get it 2, 2. Now ARY2 dot ndim is equals to 3-dimension. Sorry, ndim is equals to 3-dimension. Okay. So this is how you're going to get it over here. Now this is a restriction is there. We have to always look back to the size of the array. We have to be very careful. There is something called as, you know, reshape. Okay? Reshape over here. Reshape. Resize, sorry, resize over here. Now this resize is very much similar to that of reshape, but only thing is that the flexibility is that is, it is no need to go and check it out each and every time how many elements are there. You can give it your desired shape. Okay, now let me do it. I will do it with ARY2 dot, okay, resize. Resize I'm giving it. Now ARY1, what we are having this one, right? This one I want to resize it. ARY2 dot, sorry, ARY1 dot resize, and I will give it as 2, 2, 5. This is as it is, no problem at all. It will work like a reshape only. I'll give it as NP2. NP2 is equals to, you're going to get, sorry, this is a permanent change, guys. Sorry, I did it. This is a permanent change. Now you see this, it has got changed. So in this case, it is not a permanent change. So what we did it, stored in a variable. In this case, it's a permanent change. This is a permanent change. So you will be getting it over here. Now ARY1 is now this one. Okay? Now this one is ARY1 dot resize. I want to do it with 4, 5. Can I do it? Yes, you can do it. You will get back to the same position what we got it back. Now the advantage of this one is you can give your desired shape. Now I will give it as 2, 3, 5. Okay, 2, 3, 5. Can I give it this one? So we are having something called as an attribute called as recheck. Can you see this? Recheck. Recheck is true means it will go and recheck the size of the array. If it is true means by default it will go and recheck it. So you see this, if I give this one, it will going to give me an error. See, NP resize function of recheck, you make it as false. That's what it's saying, because our size is different from the original size. Here it is 6. How much it is? And how many values I am having over here? 20. 20 values, you want to set it in the 30 space. It will be confused, right? So that is why it is saying usually what it will do, whatever the size you are giving, this will go and check it out with the number of elements. What I will give it over here is recheck is equals to false. I do this false. Now, okay. sorry. When I do this, ARY1, you can see this, it will be doing. Now, what happened to the extra columns, extra values? It is been given with the 0. It is being given with the 0. Now, you can change it back to any one over here. Resize. I will give it as maybe 6,8. And I will give it as fcheck is equals to false. Now you see it will be changed up. Got it? Now the first 20 is only this one. Remaining all we got it 0. So you can reshape it any desired shape. There is no limit for them. But only thing is that you have to take care of the fcheck is equals to false. There is one more way is there. Now it looks very odd, right? All zeros over here. Now let's go back my like I will copy it over here. Where is the one? This one. In this, I will give it as MP1 over here. A1 I will. Now this is what I call the resize with the help of what is this array. Now there is another option is there. I can call the resize with NP. NP is what? Numpy. And call the resize with Numpy. Okay. So you will be having that resize over here. Let me see this resize. Resize over here. Can you see this? Resize. Now this one will be behaving slightly different, guys. Now let me give it over here. I wanted this one is empty, right? I will say that 5, 5. Now when I do it 5, 5, here no need, there is no no ref check is required over here. The only thing is that you have to give the array name ARY or A1. Because this is generally I'm calling with NP. It is Numpy resize. A1 is the array. Convert that A1 array in 5, 5. In this case, what it will do is like first 20 will be filled up with this. First 20 will be filled up with this. Now next there will be, okay, let me do it something like this. Like 6. So what it will do is like first 20 will be filled up with this. Now next one more row is there. One more 2 rows are coming up over here. That what it will do, it will repeat the values. It will repeat. It will not put the 0. It will repeat values. First 20, it will be filling up these things. Then afterwards 21, 14, 22, 17, 23, 10, like that it will be filled up. Now let me see you this. This is not a permanent change, guys. Now you see these are the first 20. Okay, these are the first 20. Can you see this? All of them. And then as we move forward, it is repeating. So I will make it as here 6, 5. 6, 5. Now you see it in a much better way. These are the first 4. Okay, these are the first 4. See it as it is. Then afterwards, these 2 are repeated from the first 2. Can you see this? Okay, this will be repeated. This is the way the resize will be working. Now you can store it in the. Now this is the permanent. Now this is the case you should be very, very careful with. It will be doing the permanent change. That is A1.resize. That is array.resize will make a permanent change over here. This and reshape will not do a permanent change over here. You have to explicitly make it as a permanent change. Okay. Now there is something called as transpose, guys. We'll write it as transpose. Now transpose is again it's an it will first if you give any dimension, whatever the dimension you give it, it will reverse it. It will reverse it. Oh, I have it A1 over here. Let's take it as A1. This is a 1. This is the shape of this one. a1 dot shape is equals to 4 comma 5. Now I want to make it as a transpose. Transpose. This will reverse it. Sorry, this is a function. This will reverse it. Can you see this? How many rows here? How many rows were there? 4 rows and 5 columns. Now this one is 5 rows and 4 columns. You have it. Now this is not a permanent change, guys. You will have a1 is equals to not a permanent. Now, if you want to make it as a permanent, store it in another variable over here. Now you keep it as a3 over here. This one and a1 is this one. Now a1 dot shape is equals to 4 comma 5. A3 dot shape will be 5 comma 4. Okay, this is a difference between. Now this will not work with one dimension array. No, it will not work with a one dimension. Now next one is like there's one more way also you can do the transpose. The shortcut way is like a1 is there. This is the one. Now you can do it with a1 dot e. When you do that, this is also called as transpose. This is a shortcut way. Usually whenever you are using in a big statement, if you want to transpose anything, then you quickly use it a1 dot t. a1 dot t is also called as a transpose, guys. Remember that. Okay. Do you want me to copy them and put it in the note? So then you don't want the notes. You don't want this one then. Huh? ఇది వద్దా మరి వస్తుందా ఇది సెలెక్ట్ ఏరియా వస్తే చేస్తా లేదు reshape is this one. Make sure that, and I'm going to make it as one more. Like make it as a reshape. Reshape. Just see this. You know that how I explained it. You have this one. Go online or offline? Ashok. Huh? Link for it. Now this is a transpose, guys. Let me do the transpose over here. This is a one transpose. This one. Transpose. This is a way, and you can also do it transpose in another way. Okay, the resize I will do it, guys, as of now. resize, reshape is this one, right? Now, there is something called as flatten. Oh no, there is one more is called as swap axis. That is A1 is the one which is there. Now this is another way, guys, how to use it. Another way of doing the transpose, guys. Just check it out yourself. This is another way of doing the transpose. Okay. See this. The A1 is over here. This is the one way, and this is another way of doing the transpose. Okay. Now let me go with the next one called as swap. Now, okay, I did with the most important thing. So transpose with the 3-dimension one. So what exactly happens when I'm doing the transpose with a 3-dimension is it will reverse it. Now, for example, I'm having a transpose with a 3-dimension. I have a shape over here. Okay, my shape is equals to 3, 5, 4. This is my shape, guys. This is my shape. So when I have a 3, 5, 4 over here, let's take it 3, 5, 4. When I am applying the transpose over here, transpose, what will happen? It will reverse it. So this will come first. This will come over here first. 4, 5 will be as it is. Okay. And 3 will be coming at the last over here. So the shape will become 4, 5, 3 over here. Okay. 4, 5, 3. Now let me show you that. Let me create first a 3-dimensional array. ARY3, I will take it. np.random.rand int. Let's make it 100 to 200. Let's make it 2, 4, 6. This is my shape. Okay. Now ARY3, this is the one I got it, guys. Okay, this is the one I got it. ARY3 is 3-dimensional. Now let me see the shape of this one. ARY3 dot shape. Okay. Clear? Now 2, 4, 6. Now if I use the transpose, ARY3 dot transpose. When I apply the transpose, it will be putting me inside. I will take it into another variable called as ARY4 or NP4. NP3 I will take it. NP3 is also 3-dimension. The shape will be different. 6, 4, 2 over here. So it reverses the shape. It reverses the shape. Now if you see this one, if I want to print it, ARNP3 is this. Can you see this? It reversed it. There is 6 word blocks, 4 rows, and 2 columns. You see this. This has been reversed it. Now this is, I don't want it. This is a normal way you will be getting it whenever you do it 3-dimension. This is what you are going to get. Okay. Now, I don't want this one. I wanted 4 should be coming first. 2 will be next. Or 2, 4. My requirement is something like this. Now here the shape is equals to 2, 4, 6, right? 2, 4, 6. When I applying the transpose, it will become 6, 4, 2. Now I don't want this way. I don't want this one. I don't want this. I wanted 4, 6, 2. 4, 6, 2. Now 4 I wanted at the start, and 4 I wanted this one. This is the original one. Now this 4, this 2 should go to the last. The 6 should be coming over here. This should go last, and this should move over here. This is what I wanted. So first and foremost thing is, tell me the axis. If I am having 2, 4, 6, tell me the axis, guys, for this. 0. Okay. Now in the transpose, put down this access. Now which access I wanted? This all. Now this is my desired one. This is my desired one. Now 4 I wanted, right? 4 is which access? 1 you put it on inside the transpose. Next 6 is which access in the original? Put it the 2 over here. And 2 is which access? 0. This you have to put it inside the transpose function. When you put it inside the transpose function, this one, then it will work it out. Okay. So this index, this access, you have to put it inside the transpose function. Okay. Then you will be getting it. So I will show you. Now, previously what we did it. Now I'm having ARY3. This is a one. This is a shape ARY3 dot shape. Now I don't wanted this one ARY3 dot shape. This will be reversing it. And T stands for transpose. You know it, right? Now I applied the shape directly. I didn't save it anywhere, but I applied the shape directly to see it. I don't want this way. This way I don't want it. So what I will do it is ARY3. This is the original. It will be the same. Okay? ARY3 dot transpose. Okay, transpose. Inside the transpose, give the access. So which one should come down first? 4. 4 is which access? 1. Now 6. 6 is which access? Then 0. Got it? Now I will save this one in another one, A3. Now let's see that A3 is equals to. Now it's a big one, guys. We will take it as ARY3 dot shape. Okay. A3 dot shape we will take. Whatever we want, we will get it. You have to identify the axis. So you can play with the things. Now if you have it like ARY4 dot is equals to NP dot random dot rand int, and I wanted 100 to 200 and 2 comma 3 comma 4 comma 6. I did a mistake. Okay. ARY4, let's take it. This is the ARY4, guys. Now let me see the shape of ARY4 dot shape. Okay. Now which is the 0th axis? 2. 1, 3. 4 is which axis? 2. 6 is? Now I wanted the shape should be something like this. 6, 2, 3 and 4. Something like this. I want the shape. So tell me, guys, ARY4 dot transpose 3, 0. Now I will put this one in A4. A4 I will print it. And let me do it like ARY4 dot shape and A4 dot shape. Got it? Whatever I wanted, I put the desired shape. Okay, guys. Now, this is a way you can play with the things. The transpose is very important. It is more powerful than your what do you call it as reshape. Okay. Now you can do whatever you wanted. Now, if you want to have a combination, like if you have an array, like now for this, transpose will work only on the 2 or more than 2 dimension. It will not work on 1 dimension. If you want to reshape the 1 dimension, no, it will not work. This is only used to transform the shape. That's it. It is used to transform that. Now it is, if you have an array, now just take it like my array is like np dot a range. What the a range will do? What the a range will do? Huh? So what numbers? Which array it will generate? Which array it will generate? We are talking about Numpy, right? I'm not talking about the numbers, I think so. 1D, one dimension array it will generate. Okay. So this generates the one dimension array. It will take the starting number and it will take the ending number, whatever it is, like 30 or 40, whatever you take it. One dimension, that's right. Now, here I will give it as I'm going to make it as A or A1. A1, I'll give it over here. Now you see this A1, I'm going to get something like this. Okay. This I don't want it to be in the one dimension. One dimension. This I don't want it to be one dimension. So what I will do it, I have to use the reshape. Right? I will use the reshape or resize. Now that I can apply it directly over here. So what is the total number of values we will be getting it over here? 20. Right? I make it 4,5. This you will be getting. So you can apply it like this, guys. You can do the combination of both. So this will generate the one dimension. That one dimension I'm doing it. You can't apply the transpose over here. This one you can't apply. You can't convert this one. If you do the transpose also, now you see this. E1 I will give it np dot a range, and I'm saying it 1 to 30. Okay. Dot transpose. You are applying like this. It doesn't make any difference. The same one, because the transpose is not applicable for the one dimension. You should have a minimum 2 dimension for the transpose. Okay. Here there is one more, is called as swap axis. np dot swap axis. ARY1 is this one. No, it's even worse. np1 is equals to I'll give it as 100 to 200, and I will make it as 4,6. Okay. Now np1 dot swap axis AXES, guys. This is np1 dot swap axis. I wrote the spelling wrong. Correct over here. Swap axis, yeah. Swap axis. Now the limitation of the swap axis is it can transform only 2 dimension. Only it can transform only 2 dimension. Now if I give it something like this, so okay, I have to give the dimensions. It's like I give it as inside this 6,4. I will do it something. 1,0. So what is I did it is I use the axis of these two. The axis 4 shape is 4,6. This is 0. This is 1. Now what I did it is I put on the 1 first and 0 next. That is, this is transforming the 4,6 shape into 6,4 over here. I will give it in some V2. Now let me do the shape. np1 dot shape is equals to this one. V2 dot shape is equals to 6. Now as if it is more than 2 dimension, if it is 2 dimension means it can easily swap it off. If it is more than 2 dimension, like for example, ARY3 is there. This is the one. The shape of this one is ARY3 dot shape is 2, 4, 6. Now, what swap axis can do it is, it can swap only 2 axes. Any 2 axes you take it, it will swap it. But more than 2, it will not swap it. Now you see this ARY3 dot. If I use the transpose, guys, I can swap it all the 3 axes. No problem for that. If I wanted this one to be the first, and 0 and 1, I'm going to get it. Shape will be 6, 2, 4. You are going to get it. If you see the shape over here, you will get it 6, 2, 4. Okay. Now this is the power of the transpose, but the limitation of the axis is S3 dot. I will use it swap axis. It can transform only 2 axes. Now let's take it. In this is the original array. I want to shift this 6 to 2 to 6. Only 2 swapping. 6 I want to go to the 3rd dimension, and 2 I have to get it to the columns. Then what is the axis of 2? Is 0. What is the axis of 6? Now I will give it 2, 0. Now you see this. This is going to. Now if you see the shape of this 6, 4, 2. Now if you give anything more over here, like lastly I want to give it as 1, this will not be accepted. Arguments. It accepts only 2 arguments. So it can swap only 2 axes only. Now if I store this one in the E3, A3 is something like this, and I want to see the A3 dot shape is, and B3 dot shape is equals to this one. Okay, guys. So this is the way it will be working on. Now, if you take it 3 dimension, 4 dimension, 5 dimension, also you can swap only 2 dimensions. Any 2 dimensions you can swap. Now there is next one is called as flatten. Okay. Now flatten is the one which is used to flatten the array. Now I have it ARY3 is there. Now, what is the dimension over here? 3 dimension. Right? Now I want to flatten this one to the 1 dimension. So I will use it like, okay. Now I want to make it as a 1 dimension. ARY3 dot, we are having something called as flatten. Okay? Flatten. Now when we do this flatten, automatically it will flatten on the basis of row major. Row major means first this row will be coming, then this row will be added up, then this row will be added up, and this row will be added up, and it will make it a 1 dimension array. Okay, it will make it a 1 dimension array. Now you see this first row. Check it out. 22, 122, like this. 6 of them. Can you see 6 of them? Followed by next row, followed by next row, followed by next row. Can you see it? 128. This is the next 6. And then you have next 6 over here, and next 6 over here, like this. It will be flattening it completely from here. This is the next 6, and this is the next 6. First it will finish it off this block, and then it will come to the this block. This is nothing but it is order is equals to. So if you check it out over here, there is an order is there. Order is C. C is like contiguous. This is a row major. Can you see this? That's what I said. This is called as contiguous. And now there is one more way is called as ARY2. Let me take it as A2. I got it A2 like this. Now A2 dot shape is equals to 6, 5. Now if I want to do it, A2 dot flatten. Then it will do it flattening on row basis. This is the first row, second row, third row, fourth row, like this. It will flatten. Now, this is not a permanent change, guys. If you want to make it permanent, store it in a another variable. A2 dupe. Get it as this is a permanent change. Now, the A2 will be the same. A2 will be the same. It is not a permanent change. So you don't want this way. I wanted on the column basis. I want the first column 14, 17, 13, 14, 14, 17, and like this you want. First column should be coming up over here. Second followed by the second column. Third column, the major is column major. And what I will do? A2 dot flatten. Here we are going to put order is equal to S. This is called as flattron and photon, and this will be flattening based on the column major. I see this 14, 17, 13, 14, 14, 17. Can I see this 14, 17, 14, 14, 17. Then there is again 17, 19, 15, 13, 17, 19, 15, 13, like this. To understand this is called as, this is very important. Will be asking you the question on this. By default it will be an order will be C. If you have the by default order is C, guys. Default order is C. The same thing you're going to get. This is a default order. Now you can do the things. Let me it. This is called as flatten. Now, there's a lot of scenarios you'll be using this one very, very quickly. We will be using this. Like it's not a program we are going to write. We'll be using very quickly. There is another way is called as Rabble, guys. Now, this one we are calling with the help of an array. Remember that any function in Numpy or the pandas, there is two ways of calling it. One is Numpy itself using NP. Second, some of the set of the functions will be you are calling them using the array name you will be using it. So this flatten is a one we will use it to call it with the array. Now there are something else is there over here. I showed you, that is resize is the one you have to call it with the Numpy, but reshape is the one which we will call it with the array. Remember that. Son, I think I explained you, right? The row major and the column major. Row major and the column major it is. చెప్తున్నా మసాలు ఉపయోగిస్తారండి. రీషేపింగ్ చేయడానికి చాలా సార్లు ఉపయోగిస్తారు. డేటా లోపల డేటా రీషేప్ చేస్తారు. You will be getting a lot of data. Data mining, data analysis, you will be reshaping the whole structure of the data. A data mining, data manipulation. It comes under the EDA. Okay, and this is also effective with the images. Now, I told you, right, in entire image will be stored in the form of an array, and you will be using a lot of when there is a lot of big images there, and the image features are in the center. Image features are in the center, and the other side, the big image is on the outer side. There's a base stage is there, background or something like that. Like just take it, you're having an image of an horse, Horse image is in the middle, but backside is mountains and grass and all those things. It becomes a very big image. I want to cut it off, means I will cut it off over here. There is a way is there, we can cut it off. Using the reshape, and you can cut it off them, whatever you want. It's not like that. You have to remember, it's not always like NumPy based arrays are not permanent. Okay, there are a lot of arrays will be there which are not permanent. Okay, it's not permanent, or it's not at all permanent like that. Don't keep it such rules. You will be confused a lot. Okay. Now next one is called as Rabble, guys. This Rabble is like it on the base of array. You will not have any Rabble over here. If you check it out, okay. NumPy np.rabble, we have the Rabble over here, and you can call it with the array also, a2.rabble array. Now here it will also flatten the array, guys. It will also flatten the array, and if you do it over here, this is not a permanent change. Now if I this is again the order is equals to row based. C over here, when you do it the C over here, the same thing happens. So you will get the same thing. There's no difference at all. It's not a permanent change. Now this can also be called with a Rabble with NumPy order is equals to F. Okay, sorry, I have to give the array over here A2, because I'm calling it with the NumPy, so I have to give the array over here. I give the array. Can you see this? You got it on the column basis. This I got it on the column basis. 14, 17, 13, 14, 14, 17. That is what it is, the column base. Again, this is not a permanent change, guys. This is not a permanent change. Nazia, we call this one with a NumPy, but it is not a permanent change. Just make a note of that. So you have to remember it. There's no other way is there. You have to remember them. So there are one more function is there, like round. There is, okay, let me do it some more functions like before getting into the manipulations. This is all is reshaping, guys. These all are reshaping. Rabble and flatten, swap axe. This is a replica of an alternative of flatten. That's it, nothing different. So there is some more important functions are there, like where function, round function, augmax function, and augmin function, and these are some of the functions you will be using very oftenly in our data science. So let me finish it off this one also, then we can jump into the manipulations of the array. Okay. Now where function will be working like a if condition. It will be working like a if condition, and this is very, very effective while converting the data, guys. Okay, while using the encoding techniques, this is very effective. This will be acting like an alternative of the lambda function. So how you will be doing this one is you will be using the np over here, np dot where. Now in this, three parts will be there. First one will be the condition over here. First part will be the condition. This condition will be having two possible outputs. One is a true or false. If it is true, we will be giving it true output over here. And if it is false, we will be giving the false output over here. Output. Now let's see this. Okay. Now this is like, I will show you a small example. Now I have a condition over here. Now I have an like a is equals to 100 and b is equals to like 50. I have a two variables over here, 100 and 50. Now what I will do it is np dot where, okay, np dot where if a is greater than b, then I will give it as a is an output, or I will give it as b is an output. So this is a condition. If this condition is true, then a should be coming as an output. If this condition is false, then b should be coming as an output. Okay, so now check it out. What will be coming as an output? A. Okay, a will be coming as an output. Now this one, with the help of the what do you call it as apply function, this is very, very powerful, guys. With an apply function, this is really very powerful to convert the data. This is one of the EDA techniques we are going to use it. Please remember this. Now if you have multiple values, now np dot where I have it c also over here, c is equals to like 200. Okay, now I will give it as a is greater than b, okay, and a is greater than c. Then what you are going to give it? A is an output. Else, okay. Now what is the output coming up over here, guys? What is the next one will be coming up over here? Huh? np dot where c, if b is greater than c, then what you are going to give it? B, else c. Got it? Now let me run this one. What I will get it? Okay. How we use the inline if, the same way you are going to use it. If a is greater than b and b is greater than c, if it is true, I want to give it as a, right? Else what will come down, guys? Else, because 3 are there, a, b, c, 3 are there, so you will use one more if over here. If b is greater than c, sorry, this one is a is greater than c, sorry, a is greater than c, b is greater than c, else, sorry, it should come down the b over here, starting b should be there, else I will give it as c over here. The same thing I applied over here. See, first np dot where if a is greater than b and a is greater than c, if this condition is true, then a will be coming down. Then there ends the problem. If this condition is false, then it will go to the next one. In this, I applied one more where condition, where I'm checking it is b is greater than c. If b is greater than c, b should come out, otherwise c should come out. That's what I'm putting out over here. This is very, very effective when you are dealing with EDA techniques, guys. Now practice this one very clearly. It is very important. Now if it is 600 is there, 600 will be coming, guys. Here also 600 will be coming. Okay. Now there is round is there. This round function is specially used to round up a value. If there is any values are there. Now if I have it some value like np.random.randint. Is that? అక్కడే కూర్చోమంటాడు డైరెక్ట్. ఎప్పుడో బ్లర్ అవుతుంది, ఎప్పుడో వస్తున్నట్టు ఏం చేస్తాడు ఆయన? ఆయన కూర్చొని చూపెట్టాడు. ఎప్పుడైంది? ఏ టైం చెప్పినా ఆ టైంలో వస్తాడు బాబు. ఏ ఇంటర్వెల్ లో వస్తాడు? టైం చూసుకుంటా. Now I will create one array, guys, over here. like I will say that list of 5 numbers. I'll give it as X. Now this is having how many decimals? Like 8 decimals are there. Usually you will be getting it like this, 8 decimals. So I want to round up this one to the only 2 decimals. I want to give it the 2 decimals. So I will use it at np.round. Okay, there is a function called as round over here. It's there with the round. Yeah, it's there. It is round. And here give the array. X is the array. And how many decimals you want it? 2 decimals. Give it 2 decimals. Now you got it. Got it? So these are some of the very important things, guys. One is where condition, round, and there is something called as trunk. Okay, there is something called as trunk will be there. X dot or np dot trunk, I think so. Okay, this will take the X. So let's check it out what it will do. It will give us the directly output only before the decimal, whatever is there, integer value, it is going to give us to us. Okay? This is the way it will be working out, because this is 0, this is 0, this is 0, whatever is there, you will be getting it. I will show you one more, you will get a better idea. Y is equals to 0.5 and 5.2, 5.2 and 5.7, okay, and 8.9. Okay, guys, see this. If I trunk it, when I use that trunk function, what it will do is like it will give only the integer part. It is least bothered about the decimal part. It will not consider at all the decimal part. Now you see np.trunk. Okay, here I will give it as X. So you see only the integer. Sorry, y it is only integer part. Even though it is 8.9 is there, 8.9 is there, this is not considered at all decimal. So it will be considering as, completely as a normal one over here. Only the integer part will be considered and it will be giving us. And there will be a lot of scenarios will be there where you will be ignoring the integer part and you will be doing it. For example, if a person or an employee details are there, if you ask him the age, now the data is consisting of the age in the month also, age and the month. You will not consider the month usually, right, while calculation. So I will ignore that part completely. I will ignore. There you will use that round will be, don't get confused, guys. Round will be rounding up the decimal points, and this will be, what it will do, it will take only the integer part. It will ignore the complete decimal point. Okay, will not consider the decimal point. And there is one more is there called as argmax. And this is also a Numpy array one over here. Once you take, it will give us it will take the array and it will give us the maximum array index. Whatever the array which is having the maximum value, it will give us the array index of that. Now you see this, I'm giving it I. Okay, I consists of which one is a maximum? This one is a maximum, right? So let me do this one. P. What is this? P is index. This is 0, 1, 2, and 3. This is what you are going to get it. 3 over here. So when I'm giving argmax y, then it will give us the index. Now I want to see the value itself. Then you can give it like np.argmax. The array by np.argmax. See the value. You see the value. This you can apply with the two-dimensional array also, guys. If you have something like this, you want to find out the maximum values on the row basis. Now np.argmax, max. Here I will give it as A2. So this will be giving me 6 is a 1. Now, which is the 6 over here? E2 6. Huh? It's giving us an index for me? No. It is giving the maximum value to what is there inside this. It is not there. It should be an access. I have to give it, I think so. Access is taking as none. Access is equals to 1. I got it here. See the first row over here. Yeah, first row. I'm having the 1 is the maximum over here. 1 index. Second one is 19 is the maximum. In this 2 is a maximum. This here, and in this 4 index is a maximum. In this it's given as 1 as a maximum. 1 is 14 is a maximum. Sorry. Which one is this? 17. Sorry. Now this one is 19 is a maximum. Like this you will be getting it. If I give it as 0, guys, np.augmax, I'm giving it augmax a2 of access is equals to 0. Let me do this. Then I'm getting it in this way, I think so. 1, 1, and 17, and here 16 and 17. Now here it is 0 is access 0 is taken as row, and access 1 is taken as sorry, this is column. Sorry, this is row and this is column, guys. This access 1 is taken as row. This one row, and access 0 is taken as column. Now this how it is working is based on the data. Data means whenever you deal with the data, now this is a numbers matrix is dealing with the numbers. Whenever you deal with the numbers, so usually the row will be given a priority over there. Row will be given the priority. But when you are dealing with the data means like in a tabular format, if you have some data, the column will be given the preference. Now I will show you what I exactly mean. Now A2 is there. This is the one. A2. I want to get the, let's take it 90. Let's take it as 11 over here. How you will get it, guys? A2 of first row. Which row it is? Which column it is? 3 column, right? You will be getting what? 11 over here, right? Now same 11 I will convert into the same this one I will convert into data frame. Data frame is nothing but a structure which holds the tabular format of the data. Now I will say that I import pandas as PD. Now you see the difference. PD dot there is something called as data frame. Data frame is nothing but a data structure which holds the data. Okay. Usually it will hold the data in the tabular format, and it can hold the the column labels and indexes also. Now here I will give it A2. How you see this? This is the column labels, and these are the row indexes. The same whatever is there over here, which is hidden, you can see it over here clearly. Can you see this? These are column labels and these are row indexes. Now here there are column indexes are there. No column indexes. No column indexes or no row indexes. What is this then? What is one? Row? Just now you're saying there's no index, right? It is not visible. That's it. It is not visible. It is there, hidden format. Here it is visible. There's a difference. But this is where you store the data, actual data, you will store it over here. When you deal with such a data frame, the priority will be given to the column. Priority will be given to the column followed by the row index, column index followed by the row index. Now tell me, I will give a name over here. This I will give it as df1. Okay, now df1 is this one, a2 is this one. Is that same? Yes or no? Yes. Now if I want to get 11, how you get it? A2 of 1, 3, right? This is a row followed by the column. Now I want to get the 11, same 11 in the df1, same 11. There is this 11 over here. Now df1, first you have to give the column. What is a column? Okay, which row it is? One row. Can you see it? One row. This is the difference between a data structure which deals with only the numbers, that is the matrix, and that is the data frame which deals with the data, actual data. When you deal with this is the difference. That Augmax is considering this one as, you know, access of, this is the access one as row, this is column it is. That is a difference over there. Okay, Augmax is specially used for the data level. Okay, there is an augmin is also there, np.augmin. This will get it minimum value, guys. This will get the minimum value. I will say that y, you will see that 0 index. Now y of np.augmin of y, if you give it, भाई डाउट है क्या? ज्ञान बांट रहे हो ना? हमें भी बांटो थोड़ा. ले रहे क्या? 0.5. 0.5 like this. The same way it will be working with the 2 dimension, guys. np.augment of a2 of access is equals to 1. So this will be giving me 2 3 0 2 2 3. This is nothing but a2. This is 2 is equals to 2 over here, 3 is equals to 3 over here, 0 is equals to this one, 2 is 2, 2 and 3. This is the way you will be doing it. Again, this you will not use it anywhere but interview. Will definitely ask you the augmin and augmax if they get into deeper and deeper into this. So round will be rounding up the values that we are going to use it. There are a lot of scenarios will be there. You will be using it, or round up. When we get it a mean, when you calculate a mean. Now, usually when we calculate the mean, you are going to get it from a like 8 decimals. So 8 decimal mean doesn't make any sense at all. This is such a big value. So what we will do it is mean and standard deviation. We will cut off to the 2 dimension. In order to cut off to the 2 dimension, we will use the 0.2 decimals. We will use the round. Okay, guys. So these are some of the functions. If I miss it out anything, we are going to add it by the end of this. Not in this. By the end of tomorrow's session, if there is anything is missing, I will be adding it. This one is really very important. This is an alternative of your lambda function. Okay, let's do with the manipulations of the array, guys. What we have done it, the reshaping of the array and some of the built-in functions we have seen it. Many more are there. There are a lot more are there with a function. There's a max, there is min, there is sum. All these are there. Max will get the maximum value, min will get the min value, sum will give you the, again, the row wise sum and column wise sum. Access 1 is nothing but the row wise sum. Access 0 is the column wise sum. These are also there. I don't think so you require that, right? Silent means that is yes. There is mean is there, and mean median is there. That yeah, median is also there. Dot median. Median mode is also there. These things will be very, very effective when we deal with the pandas, guys. Let's don't waste much time in this. This copy is there. B view is there, and SD. SD is a standard. STD is a standard deviation is there. अब variance वो पूरा वहाँ पर मिल जाएगा. We will get it in Numpy. That is, sorry, pandas. We can do it there. That makes some sense. Here it will not make any sense. Okay. Previous notes are. Yeah, I uploaded it. Amit, just check it out and then raise that point, right? Please check it out, guys. हाँ? मतलब नोट्स नहीं है बोले तो मैं झूठ बोल रहा हूँ क्या? फिर उसका मतलब वही है ना? हमारे वीकेंड मूड से बाहर निकलो क्या? इसलिए बोल रहा हूँ वीकेंड मूड से बाहर निकलो बोल. सच में ये क्या होता है? ये वाला नहीं, ये 7:30 का. ये देखो दिखा रहा हूँ ना, ये देखो ना, वहां पर क्या देख रहे हो? यहाँ पर देखो ना, यहाँ है ना. लेना का है क्या मोबाइल? इसलिए ये लो है ना. गेटिंग इट देयर. नहीं हो रहा क्या? और कुछ? हाँ? नीचे जाओ ना, नीचे है ना पूरा. यहाँ पर जो भी करे सो अपन. ये देखो सही ब्रॉडकास्टिंग रूल्स. आई सेड यू ऑल्सो गाइस, आई एम यूजिंग द सेम स्लाइड ऑन दिस. हाँ? फीस पे करे, फीस पे करे तो नहीं आता फिर. अमिता आप देख लिए? Okay, now let's move on. Now let me explain this one, guys. Copy and view, and these are mean, median, mode. These are the ones we are going to deal with very detailedly while dealing with the statistics. I don't want to give it and make a confusion for you people over here. We will see this one very detailedly along with the formulas and derivation, everything. In the standard deviation also we are going to do that. This one. Okay, just ignore this one. But there is now most important thing over here you have to remember is one is where, next one is round. These are the ones you have to do it. There is something called as NAN. What is this stands for? हाँ? आप कुछ बोल रहे थे? हाँ बाबू, मास्क राइट. हाँ आईपीएन या पाइथन? एनीवन? नंपाई किसका हुआ? This is called as NAN stands for not a number. अरे जस्ट मिस यू. बोलना था ना बाहर, फिर बाजी बोले तो ऐसी होता है फिर. Okay, so NaN stands for not a number, guys. This is very, very important. This is a part of np.nan. Remember that this is np.nan. What this is used for is, I'm patching up all the things. You will see this one is very important in our pandas. Now you are having errors, guys. What are the errors we will be having? What type of errors we will be having? Outliers, noisy data, and missing values. These are the errors you will be finding usually in the data. Okay, there will be again some more will be there, like mixed values will be there, the data with numbers with the characters, or top 3 will be the numbers and then the characters will be there. There will be a lot of scenarios will be there. There will be error, but overall the errors will be like this. Okay, errors will be like this. Now what we will be doing this errors is, we are going to identify all these errors, guys, and we will give them, we will remove these errors, and we will standardize these errors by giving them a standard value called as NaN. All the errors we will be just standardizing them with an NaN over there. Okay, NaN. Now this NaN, why we have to give it is, this is not a string, guys. Remember this. If you want to invoke NaN into any table or any data set, use it how? np.nan. Remember that. This is an np.nan. So when you give it np.nan, इसका नाम पूछिए. The people are not there. Huh? Enter the session, no, right? Okay, guys. Now this is np.nan. Now what is the specialty of the pandas is, pandas will be, we are going to convert everything into NaN. Converting means don't put it as string NaN. No, it don't look different at all. Both will be the same. If I put it string NaN and np.nan, both will be the same. There won't be difference at all. Now I will show you over here. Now I am having something like z is equals to n, guys, n, and then we'll give it as NaN. No problem about that. And then let me do it like here. I'll give it as Rabble, and this is an NaN. Then I will give it as np.nan. See this. Okay. Now if I run this one, z is equals, can you see this? This is an NaN and this is an NaN. Okay. Usually when you use the pandas, you will not even get the difference over here. Now let me show you. pd.data frame. I will give it z. Can you see this? Which one is NaN? Which one is this one? It's very difficult to know it. Now here you can see it because Numpy is not designed for the character data, so it is showing it. When you go with the data frame, you see this. Both are same. This one is NaN. This one is string. This one is giving an np.nan. Is not a number. Now, why we want this one is, to see this, there are specialized functions are there for identifying the NaN. np.nan. The specialized functions are there. Now, there is something called as pd, or if I give it the name of this one is df2. df2 is equals to this one. If I say that df2 dot, okay, I will say that as fill NA. fill NA. Fill means filling, NA means NaN. Okay, this is the function which identifies the NaN value and it will fill it up. Now I want to fill it over here. I want to fill it with a fruit over here. Orange. Now, which one will be filled up? The last one will be filled up, not the middle NaN. Why this one is not filled, guys? Because that is not an np.nan. Remember that. That is not an np.nan. Now, if I give it over here, see this. I'm giving over here as np.nan. Okay. Now, what will happen is you got it both as nan. Now, I'm converting this one. Both are nan. Now, you won't find any difference. Now, when I rechange it, because both are same, orange and orange. Got it? Orange and orange over here. This is what it will be happening. Now, this is the way it will be doing it. Now, this is a function which is very, very important for us. Where is that NaN? Down. This is the one which is very, very important for us. Okay, this is one which is really very important. Okay, this is where you will be converting all this, and there are some built-in functions are called as fill NA, and and there is something called as interpolate. This is also, it will identify the NaN, and drop NA. If you want to drop it of the NaN when there is a, these are the functions which are. Now this NaN is really, this is the one which is really very important. So there is a copy function is there. Copy function will be copying the data. There is something like, I will give it as y. Y is this one, right? If I give it y, y is equals y dot copy z. These two are two different instances, guys. Both are, or let's take it as E2. A2. Now A2 is nothing but, this is the one we are having it. Now I want to do it. B2 is equals to A2 dot copy. A2 dot copy. Now I will give it as B2 is equals to this one, and A2 is equals to this one. Now these two are two different instances. These two are two different instances. If I change any one, that will not affecting the other one. A2 of, now I want to change this 15, not 15 to 555. How to reach 15, guys? 2, 1. This will be getting me 15. I want to replace this one with 555. Now you see this A2 is having 555. Now B2 will not have. The both are two different instances. Okay. Now if I do a view, then they will be pointing out to the same memory location. If I do it A2 dot view, okay, and I'm giving it in C2. Now C2 will have the same 555, and A2 is also will be having. This is a copy which is happening. Now I will change it, this one, to maybe 5, only 5. There is A2 of 2, 1. I'll give it as 5 over here. Now this one is changed. 5. Right? Now I will give it C2 over here. C2 will also be affected. Both will be pointed out to the same memory location. But if you are doing the B2, it will not be affecting us because both are in a different memory location. So these are some of them which are the functions which will be using it. Now let's do with manipulations of the Now manipulations of the array is nothing but will be an existing array will be doing. You will be applying some manipulations on this. One is called as insert. Second one is called as delete, and next one is called as append. These are the ones, and there is one more like manipulations is called as concatenate. Its function is there, and another one is split is also. These are the functions which are there. Concatenate, split will not use it anywhere, but these are the ones you may have to know it. You may have to know this. So this one is, it will insert a value or a series of values into an array. Now this one will delete a single value or a series of values from the array. This one will append a value, or now value means a single value, you can append it, or you can append a row, or you can append a column also. The same thing. This one also a single value, you can append it. You can append the row or a column. You can insert a row and the column. So let me show you this one. Now I will give it as C2 over here. Now C2 I will do. Now there is insert. I will do it now. Insert. This is an insert is with NP. Now there will be an attribute over here. First one is you have to give the array, guys. Over here. Array. Now array means the original array, whatever you want. Now next one is object. When you say this object, this is nothing but the index, in which index you want to insert it. Now the values, this is nothing but it is a single value or a row or a column of values. Whatever you want to give it, you can give it the values over here. Then this is a very important one called as access. So in this, the access will be three type of access. One is access is equals to none, guys. This is a default one. If you take it out, it is the default one is none. Now next one is access is equals to 0. That is the row wise. Access is equals to 1. This is a column wise. Remember this. Row wise and column wise over here. Row wise. Column wise. Row wise and column wise. Now see, access is equals to none. Okay. When the access is equals to none, guys, suppose I want to enter a value over here. Just take it. Now I'm having np dot, np means numpy dot insert. Inside this, I'm having multiple. One is the array, the index, followed by the values and the access. Now here I will give my array is ARY1. I want to insert a value over here. I will say which index I want to do it. Maybe around 2 index I want. The index is 2. Now if I give it a value is 5 and I'm giving it access is equals to none over here. So what it will do it is, when I'm giving it as none, okay, I'm giving it as none. So what it will be doing is, it will convert the access. Now this may be 2-dimension array or 1-dimension array or 3-dimension array, whatever may be the dimension it will, when the access is equals to none, it will convert the array into 1 dimension and it will identify the index 2 and then it will insert the 5 over there. Whenever the access is equals to none, if the array is 1 dimension, 2 dimension, 3 dimension, or whatever the dimension, it will convert into 1 dimension and it will identify, it will flatten up. Completely it will flatten the array, and in that it will identify the 2, index 2, and it will insert the 5 over there. Okay, this is what will happen. Now when this will flatten the array first. Flatten the array and it will do it. Now let me show you this one, guys. Now this is the one, my array A2, A2. Now I want to insert, my intention is I want to insert at this location. that is 2 index. I'll give it as 2 index. What value I want to insert? 9. 9, 9, 9. 3 nines, 4 nines I want to insert. So my intention is this whole row should be having 9, 9, 9 like that. Okay. Now I will give it as access is equals to none. This is the default access. If I'm not giving also, that will going to come down. So what it will do? First, it will transform the whole array into one dimension array. Then it will be like it will identify the 2. Then you transform itself into one dimension array with the order C. Order C means row wise. When you say that order C means row wise it is going to get it. Row first, this will be the row, then this will be the row, then this will be the row. It will be coming up in a one dimension, and then it will identify the 2, and that will insert at 2, 9, 9, 9. It's flattened into one dimension, guys. Can you see this? Flattened into one dimension, and you know 0, 1, and 2. Previously 2 was what? 10. At 10 place, it inserted what? 999, and it pushed this one 10. Okay, this is how it will be working out. Now you should be very careful while doing the insertion. You should be giving it. Now again, remember this, there is a restriction over here. You can enter a single value or a row of values and the column of values. Whenever you are giving a single value, then give the access is equals to none. Okay, if the access is equals to none, it will flatten that one and it will insert the value at that location. If the access is equals to 1, access is equals to 1 and a single value you are given, then the entire row will be having all 999. Okay, now you see this one. If I am giving it the same, access is equals to 0 over here. Just I am giving 0 stands for row over here. Okay, row. Now what it will do is like entire row will be filled up with 999 over there. I will make it line. Now if I want to put a single value, this is a scalar value. Single value means scalar value. Now if I give it over here as 1, okay, then you will get it in the column. Okay, this is the way. Okay, clear guys? So you can just do the things as per yours. And now one more thing is that I want to enter this one at multiple locations. Then you can do the multiple indexes over here. Now I will give it as insert. Okay, A2. I'll give it at 1, 2, and 4 I want. And I wanted 999. I will give it as access is equal to 1. 2 places I got the 999. Okay, remember. Now if I wanted in the row way, let's give it as access is equals to. Now one more thing. Is this a permanent change? Kada. Chud malla. It's not a permanent change. It's not a permanent change. The simple way of knowing this is whenever you execute it, you are getting an output. Then that is not a permanent change. You have to explicitly make it a permanent change. Now, when you do that, when you execute it and you're not getting any output, then that is a permanent. Okay, simple way of remembering it. So I will show you over here. This is 0. 0 means row wise. Okay, row wise. Now, how many places? 2 and 4. I want to enter 999. Now you see this. You will be getting 2 and 4. I got it 999. Here I am getting an immediate results over here. This is a view. It is giving us a view. It is not making a permanent change. It is giving us a view. Now let me take it A2 over here. A2 dot resize. Resize is there over here. Yeah, resize. I want to resize this one too. What is the shape of this? A2 dot shape. 6, 5. Now A2 dot resize to 2, 3, 5. Can I do this? Already I can do this. Now if I do this, no output. I didn't get any output. Why? This is a permanent change that is been changed inside A2. Now you see. So easy way of remembering it. Okay, everything remembering will be very difficult. Try to find out the techniques over there and you can do it. Okay guys, now insert we have done it with a single value. Okay, single value we have done it. I want to insert a row of values. My A2 is equals to row. Now I have to resize it to 6, 5. Can I do this? A2. Okay, this is a one. Now I will give it as A2 is equals to A2. Okay, A2. Now inside this, I want to insert a row of values. Now till now I insert a scalar value. Scalar means single value. Now I want to insert a row of values. Now just imagine guys. Always you see this. Whenever you deal with the Numpy arrays, they are perfectly structured. No value will be more or no value will be less. Now how many elements are there in the first row? The same number of elements will be there in the rest of the rows. Okay? How many elements are there in the one column? The same number of elements will be there in the all the columns. Okay. Now if I want to enter something into this structure, I want to enter something. So my list of values will be equal to the number of elements in the rows. Okay, number of elements in the rows. Now suppose this is the row is there. This is how many elements are there in the row? 5. Okay, 5. First one 5. Second one 5. Last one 5. All of them are 5. How many elements you have to enter? What happens if you enter 6? It will not take, because that is not that structure is completely lost. It should be a perfectly number of elements in the rows, in all the rows should be equal, and number of elements in the all the columns should be equal. Okay, remember that should be equal. Now if I want it like value, I want to enter it A2 dot insert inside this A2 comma. Now which index I want to enter? This index. What is this index, guys? 3. Right? 3. I want to enter the values over here. List of values. I want to enter list of values. Now I will enter like maybe 100, 200, 300, 400, and 500. Will that be okay? Yes, it is perfectly get into that, into the structure. It is not disturbing the structure. Now what should be the access? Access should be 0. If I give it none, will it accept? No. It will accept on what will none will do? First step, flatten it. After flattening, you enter the 5 values. What is the problem? You will enter it. No problem. Now here I will end it up over here. Now if anyone is more over here, okay, sorry for that. Anything is more there. See this, I'm giving it less, I'm giving it less. It will not accept. 1, 4 into the 1, 5. You are entering a row with one row with 4 values into one row with 5 values. That is not going to match. That's what the broadcasting rule over here. Okay? It is taken as a broadcasting rule. Now, so what you have to do, make sure that this cannot be more also. Guys, you can't be giving more also. Now, if I don't give it this one, can I give it? Yes, you can do it. Because what will happen if I'm not giving the access? Default will be none. None will what it will do? It will flatten the array and it will take it. Now, that should not be any problem. Okay, guys. So you should be getting an idea. So let's insert something into the A2 column, A2, comma, 3, and I want to insert along the axis. How many are there inside this? 6 are there, right? Along the column. 6. I will say that 10, 20, 30, 40, 50, 60. Can I insert it? No problem. You can insert it. But you have to give it as axis is equals to 1. You inserted it over here. 10, 20, 30, 40. Now, if you want to insert it multiple location, you can give it over here. Just give it multiple location 2, 3, and 4 also you can insert. The problem? Should I give the list of values? Access is one. Why it's not taken? Broadcasting fix 3, 6 and 6, 0. It's not a problem. If I give it 2, this should not be a problem. It is giving me an error. Give it over here, right? Where is that? Where it is multiple values. I give it over here. Okay, this one I give it. I didn't enter the rows, multiple rows. Now, why it is showing an error is this is what it is expecting. I will tell you the things I'm having. So it is saying that it is 6 is there, and you are giving 2, 6. So here, what exactly is happening is just it is considering something like this. I'm giving it 2 values over here. Just give me a 1 value over here. Just let me do it. A2. I'm giving it 3, I will give it as 100 to 100. 100 to 100. Now I will not give the access. What will happen over here? This will flatten the list, flatten the array, and go to the third index, and it will enter this one, right? Enter this one. Now, if I am doing it something like this, np.insert A2, I am giving it like 3, 5, 8 or 6, something like this. And I'm entering a value called as 999.